maybe I'll just start to say for a minute or two, and then I'm going to hand it to Akiko. And maybe just five of us can introduce ourselves, just to say hello. Leslie, you want to?
Sure. No, I'm here on behalf of Hugo Health and Kindred. I just wanted to welcome everybody and appreciate everybody's engagement here. For those of you that came to our cafe last week, that it was just an incredible exchange of ideas and conversation, and really appreciate people that were there. You know, we're here to serve you guys. We want to have we want to be sure that your voices are heard, whether it's by participating and listen or joining some of the other activities that we're doing on the Kindred side. Talia is also here, who's our community manager. She's been capturing people's stories and putting, posting those stories on the Kindred site. There's lots of great content that's showing up there. There'll be more coming. So please, reach out to us if you need anything. And, as Harlan said, this is the first Listen Town Hall meeting. I know they have plenty more that they'd like to do with those of you that have signed up for the study. So I'm going to pass it over to them. And again, thank you so much. And we're really excited about what's coming forth. So I'll pass it on to Harlan.
I'll just say, I should have introduced myself. So I'm Harlan Krumholtz. I'm a professor of medicine at Yale. I'm a cardiologist and also co-founder of Hugo and Leslie's husband, which is probably one of the nicest things about me. And we're here with Bornali and Cesar, who are key members of the Listen team, and we're part of the cafe last week. And of course, Akiko Iwasaki, who is going to be presenting some information about a study that we recently completed. But I just want to say for a moment that, this is all about trying to think differently about how the research is done. And like we said, this is all iterative, and maybe I think next time it would be better for everyone to see everyone's faces, to feel better sense of community. But it's unusual for research study to say like, hey, let's run some town halls. Let's have some back and forth. Let's have ask us anything sessions, and also share ideas about the study, and to be able to listen. The study's called listen to all of our teammates, all of the people who are participating, so that we can think about how we can do this better and how we can race faster towards progress that will impact positively people's lives. And so far, I mean, we've enrolled largely by word of mouth. I mean, we've promoted some stuff on social media. People will join Kindred. Kindred's a community where people can interact and get information, have the opportunity to link to their data and join studies. The promise of Hugo is that people can gain agency over their data, and that the data won't move without anyone's permission. It'll be kept safe, and it's up to people as their data assets grow, whether they want to join studies and be able to help move things forward. The profiles within Kindred are meant to help match with studies and accelerate that. When we ask for stories, it's because we want to know, like, real life, like how's it affecting you in ways that questionnaires may not be able to capture. And then if people connect to their data sources, their electronic health record and wearables and payers and others, it creates a rich source of data about them that they have agency over. And then if they consent to be in a study and they think that the study is worthy of them, and then they can agree to have that data be used in the study. And it's up to us to try to make sure data doesn't move without permission. And the studies that are offered are ones that will treat people as partners. And of course, we're starting this first study, but we hope that there may be many opportunities that come down the pike that will be part of this. And again, part of it is trying to foster a sense, and when I say sense, I mean authentically convey that we're interested in working directly with people. And again, other studies tend to go through sites and depend on a physician offering a study to someone, or there's lots of people in the middle between the researchers and the people participating. We're trying to say, what if it's a direct-to-consumer idea? What if it's decentralized and anybody can join? And what if we can talk directly with the group and again, listen to questions, be able to interact, and then think about how we can make progress together. For me, one of the great privileges of this study, now we'll just talk about the Listen study, and we're glad to answer a lot of questions about the Listen study as we go. But one of the great privileges of the Listen study has been my opportunity to work with Akiko, who is just the most remarkable scientist and also individual person who cares deeply about the people that she's trying to generate knowledge about to help them do better, and is also conducting science in a way with utmost integrity and leadership, and trying to think in innovative ways about how we can how we can all work together. So, and the central idea here is that if we can be able to collect information about people, their lives, their journey, their experience, and understand the diversity of ways in which they're affected, and also include people who are control populations. And by the way, when we're talking about listen, we're talking about people who are in with long COVID. We're also have heard a lot from people who are reporting vaccine injury and have symptoms that often can sound very similar. And we're very interested in working with them, respecting, honoring the kind of experience that they're having, and seeing whether or not we can reflect through what we're collecting about them and the biology, try to break through information on that side too. What working with Akiko for me is the opportunity to both profile people from their experience and then combine it with this deep immunophenotyping that she's going to talk about, really the very best science that we can imagine, and being able to generate lots of data about people, their experience, and how their bodies are working in order to try to come up with some insights about what's causing this and where we can go for diagnostics and therapeutics. And most importantly, to reflect back to people that we believe you, like we hear you. We know that there's something real going on, and it's important for us to work together to demonstrate what that is, and to be able to provide evidence-based guidance about what people can do to help themselves. And anyway, so we'll go on. But when people are like, even I know a lot of people have had very difficult experiences where either they're being dismissed or people doubt them or wonder if it's real. People doubt themselves even. And just to say that we're here to say that let's learn together. And again, we hope people will consider us allies in this as we try to make progress together and help us be better partners. Because we know that there'll be places where we could do better, or maybe we haven't been as sensitive as we could be or should be. And we're eager to learn about how we can be better partners. So with this, I want to turn it over to Kiko, who's got a presentation planned. And I know people are putting in questions, and we can try to, we got Bernali and Cesar who can either answer on their own, or they can tee them up for us in the second part of the presentation where we can answer them. And we're lucky to have them engaged and also part of the project. And let me hand this over to my dear friend, my colleague, and partner in this project, Kiko, to welcome you all and then talk a little bit about a study that we've recently done. So thank you so much.
All right. Thank you so much, Leslie and Harlan, for the introductions. And, I feel equally honored and fortunate to be working with Harlan and Bornali and Cesar and Leslie as a partner. So just a little bit of background about myself. I'm an immunologist at Yale. I've been studying infection with a variety of viruses and immune responses, and seeing how we can use that knowledge to improve people's health. And mostly I'm a basic immunologist, so I study basic mechanism of diseases, as well as vaccine development. We're currently working with a nasal vaccine booster strategy that will hopefully prevent any diseases like long COVID from happening in the future. So what I'd like to do today is to, well, first of all, welcome everyone. I see the names of attendees, and many of you have reached out to me, and I feel like I know you, and it's wonderful to see your names at least on the list. And some of you are superstars, you're advocates, and I really appreciate everything you do. So I'm playing a small part in this whole equation of Yale Listen study, but essentially what I want to do today is to kind of give you an overview of a prototype study that we did in collaboration with Mount Sinai School of Medicine with David Petrino's group, and give you a sense of what we can do. By the way, this is the tip of the iceberg. We can do a lot more, and we are doing a lot more, but we wanted to get this information out to people as soon as possible so that you can read about it. And in fact, this study has already been posted in medRxiv and has been picked up by, I think 80 media outlets already. So you've probably heard about it, but I want to tell you how we interpret the results. So I'm going to share the screen. Okay. All right, you can see this? Yes. Okay. So Yeah, today I want to talk about the immunology of long COVID. The reason we're studying the immune system in people with long COVID is because the immune system is it's like an amazing orchestration of molecules and cells and biological process that can tell us a lot about what's happening in a person's body, even just by collecting blood and looking at what's inside of that. And so today I'm going to focus mostly on the blood analyses, but we can do a lot more by collecting tissues and mucosal secretions. So today's focus will be in the blood. Before I get into long COVID, I want to highlight the fact that there are many other infectious agents, many viruses, as well as non-viral pathogens that can induce long-term symptoms of post-acute infection syndrome of PAIS that we have summarized in a recent review with Jan Chotka that we published together. And so Jan himself, he suffers from ME/CFS, and he has read every paper under the sun on this topic. And I kind of helped him with the strategy for this review. And essentially what you see are a lot of different viral pathogens, some of which has really no name for those diseases, but it's well known to have a sequela way after the initial infection process. Some of these post-infection sequelae can take decades to manifest, whereas others become apparent within days or weeks. So SARS-CoV-2, the long COVID, obviously, the CDC definition is symptoms that last for over 4 weeks. And that is certainly true for SARS-CoV-2, but other viruses have different onset of these types of post-infection syndromes. And there are other non-viral pathogens, bacteria, and parasites that can also cause post-infectious syndrome. The famous ones are the acute fever fatigue syndrome and the post-Lyme disease. But there are probably many others that are under-recognized that many people are suffering from without really knowing what the causative agents might be. Just taking some of the examples of literature on, say, Epstein-Barr virus, this is from the same review. What we see is studies. So different colors indicate different studies. We compile them into one graph. And looking at time since mononucleosis, which is caused by Epstein-Barr virus infection, and then the unrecovered participants on the y-axis, you see that there are a large number of unrecovered participants within about 2 months post-mono, but this percentage declines over time, and the studies are pretty consistent. But even after 24 months, this number does not go to zero. There are about 4% of the individuals who had mono 2 years still suffering from various symptoms, and many of these have turned into chronic fatigue syndrome diagnosis. SARS-CoV-2 also has a similar type of curve when you look at people who are having at least one of 12 common symptoms or self-reported long COVID and days since COVID-19. You see that there is definitely decline in these numbers, but some of these are unfortunately quite persistent. And so what might be causing these long symptoms after an acute infection? We think that there may be many different causes, and it's not that one of these mechanisms are right. It's probably many of these things that are going on. In some people, there might be multiple of these things going on at once. But some of the top hypotheses are viral reservoir or viral pathogen-associated molecular patterns. These are sort of the RNA or the DNA of the viral genome that triggers innate immune responses. And also this persistent antigen can drive T cells and B cells to act in a chronic manner, stimulating chronic inflammation. Second hypothesis is autoimmunity. it's possible that you generate autoreactive antibody after an acute infection. This is a well-known thing that happens after an infection. You generate these bystander activation of T cells and B cells, but if they persist, that could also trigger long-term symptoms. Now, C is this dysbiosis of the microbiome, the commensal bacteria that live in the gut. Their composition changes over time, and it's possible that the bad type of bacteria may be replicating in the gut to cause some of the symptoms. It's also possible that there's reactivation of latent viruses like the Epstein-Barr virus or other herpes virus family members that could become reactivated and cause some symptoms. And then it's also possible that there's tissue damage in various different organs that might contribute to inflammation. There are many, many studies that have been done, and these are just a handful of the examples that indicate possible viral reservoir. There is antigen, there's RNA, there's combination of these, viral features that are found in people with COVID months after infection. There's also EBV reactivation, the Epstein-Barr virus that I talked about just now, that was identified to be one of the 4 predictive factors for long COVID. There are also papers showing autoreactive antibodies against G protein couple receptors, as well as lupus-related autoantibodies. And then we also published a mouse model in which central nervous system damage can be caused by an acute respiratory infection with SARS-CoV-2. So there's evidence of all these things. And like I said, long COVID, it is definitely a heterogeneous disease that encompasses probably many of these and combination of these features. Oh, this is one of my favorite studies where people have found that dogs that are trained to detect SARS-CoV-2 infected supernatant identified about half of the people with long COVID, where 0% of the controls were identified by these dogs. This is a very unbiased way of detecting viral persistence, I think, in people, and it's a interesting indication of possible viral reservoir. So the study that came out earlier this year by Jim Heath's group demonstrated, by studying people who had acquired COVID and following them for 2 to 3 months, they identified 4 anticipating risk factors at the time of initial diagnosis that predispose people to long COVID. One is type 2 diabetes. Second is SARS-CoV-2 RNA-emia. This is viral RNA found in the blood. Epstein-Barr virus viremia, again, EBV DNA found in the blood, and then autoantibodies against lupus-related antigens. These 4 factors could explain a lot of the risk associated with development of long COVID. So then this is just the background, just to kind of give a sense of what's known, what's not known, and what we've done. So we have carried out our first human long COVID studies. And as I said, it's as a prototype. We plan to do this hopefully with the Yale lesson cohort and asking distinct questions about the immune phenotypes and what's driving some of these symptoms. And just wanted to introduce the team that we worked with, which is, as I mentioned earlier, David Petrino at Mount Sinai School of Medicine. He sees thousands of long haulers. He's an amazing human being as well. And I have the fortune of collaborating with him and his team, Jamie Wood, Laura Tabakov, and Dana McCarthy, and others from his team, who have been working for over 2 years together. I actually reached out to David when I first heard about long COVID during an interview with Ed Young from The Atlantic. he was asking me about what are your hypotheses about these long COVID, and that was like really the first time I heard about these post acute sequela of COVID, because it was summer of 2020, so pretty earlier on. But then in the same articles, David Petrino was quoted, and I realized that he really cares about patients. And he's very knowledgeable about the clinical features associated with long COVID. So very happy that he responded to my email and we started a collaboration. And so that's the work that I'm going to tell you about today. And of course, I'm just a conduit of what my team and others have done together. So these are really the heroes who carried out the studies, and students and postdocs. And so John Klein is the first of the co-first authors. He's an MD PhD student in the lab. Jill Jaycox is a MD PhD student in Aaron Ring's laboratory, who is also a key collaborator in this whole endeavor. Rahul is a postdoctoral fellow in David Van Dyke's lab, who does the machine learning algorithm for the study. Jeff, Sasha, Pei Wen are three other members of the laboratory who really work tirelessly to analyze the samples. And so I'm just presenting their work. So the Mount Sinai Yale, my long COVID study, was to really try to collect as many information as possible from people who have had long COVID. This is from Mount Sinai. So New York got its first wave pretty early during the pandemic. When we collected the samples, they were about at least a year out from their original infection. And we included people who are older than 18 years of age and who fit the WHO guideline criteria for COVID infection. And we excluded certain types of individuals because we didn't have a large number. As you can see, we have 99 long COVID in purple. The convalescent control, these are the people who got infected around the same time but completely recovered. 39 people, and healthy control, these are 39 people who never had COVID. And then we also had healthcare workers who provided samples for the antibody analyses. And we conducted multiple immune phenotyping. One is flow cytometry to look at cellular factors and composition and activation phenotype. We also did human exoproteome antibody analyses. This is also known as rapid extracellular antigen profiling, or REAP, a technology developed by Dr. Ring, and SARS-CoV-2 antibody profiling. This is looking at virus-specific antibodies. We also did a peptide display library. This is really looking at antibodies against virtually any epitope that we were interested in. Plasma proteomics to look at cytokines and hormones, and then of course, EMR and symptom survey. We wanted to correlate people's symptom to different immune features, and that's how we did the study. And this is in medRxiv, not bioRxiv. Okay, so the demographic of the population were similar between the long COVID and the convalescent controls. Median age was 45.8 versus 41.4. Female dominant, this is typical of long COVID. There are a lot more female patients than male patients. And then we have also, most of the people were not hospitalized. And then there were some that were hospitalized, but there was no significant difference between these groups. And days from acute COVID, as I mentioned, they were about at least a year out from their infection, around the year to 18 months or so, in both the convalescent and long COVID groups. So long COVID patients, so we did all these different analyses. I'm just going to highlight some of the key things that we found. So again, just to orient you, the healthy controls are already always in orange. The convalescent controls are in yellow, and long COVID participants are in purple. So of all the features that we looked at by flow cytometry, what we see is an elevated level of non-conventional monocytes. These are sort of, I don't want to get into the details about these cell types, but essentially these are the cells that you often find during a chronic viral infection, and they seem to be activated. We also see reduction in these conventional dendritic cell type 1. These are the cells that are known to stimulate antiviral T cells, and they're kind of reduced in the blood. We also see activated B cells. B cells are the cells that make antibodies, and they have this interesting activation phenotype in the long COVID patients. And we also see double negative B cells. These are B cells that are thought to be involved in extrafollicular activation. It's just too technical to get into what they are, but essentially this was what we saw was these cells were also elevated. And then when we looked at the T cells, so T cells are the ones that can detect virus infected cells and kill them. And some of the other T cells are known as helper cells. So the CD4 T cells are the helper cells that kind of remember different viruses and stimulate. They're like the central control commander of the immune system, and they play a very important role in every aspect of the immune system. What we saw was that in the long COVID patients, what we call the central memory cell population of T cells were reduced in circulation, whereas the exhausted T cells were elevated, both the CD4 and the CD8 types. So exhausted T cells are interesting because they are only present when T cells detect the antigen over and over. So for instance, you find these cells during a chronic viral infection. You find these cells in a tumor setting, people who have tumors that can't be removed. The T cells that are specific to that specific antigen become exhausted because they've been stimulated too long. So that's elevated. That's interesting. We don't know what these T cells are actually detecting, but it means there's some kind of chronic antigen that's stimulating this response. We also found that cytokines that are secreted by these helper T cells are elevated. So cytokines are like the languages that the T cells speak to communicate, different signals to other leukocytes or other cell types in the body. They're very important. But what we're seeing here is that these types of cytokines, interleukin 2, 4, and 6, are elevated in the CD4 T cells of people, long COVID patients, but not the others. So the convalescent controls, they were infected but recovered. They don't have these features. And if you look at, there are some T cells that secrete both IL-4 and IL-6. These double positive cells are pretty much only found in people with long COVID. So that's very interesting. We don't know what they're doing, but they do correlate with something. I'm going to tell you what that is soon. The other features we looked at are antibodies against the virus. And what we saw was that the long COVID patients have, so we controlled for the number of vaccinations, because of course, the more vaccines you receive, the more antibody you generate against the spike protein. So we only took people who had 2 doses of vaccines and then asked, what is their antibody level against the spike, or the S1 region of the spike, or the receptor binding domain of the spike? So the purple, again, the long COVID patients with 2 doses of vaccines, they had higher levels of antibodies. And that was really consistent among these participants against SS1 and RBD. And so this is interesting. Again, it suggests that these B cells may be undergoing maturation process because they're seeing the antigen over and over. That's just a speculation. We don't know why they have higher levels, but that could be one reason. The other thing that we looked at, I mean, we looked at actually thousands of factors from the blood of these participants. And we asked, what are the features that are most significantly different between people with long COVID and people without long COVID? And the number one factor, the most significant, was the cortisol, plasma cortisol level. Now, we didn't do a cortisol measurement throughout the day, which is what we're planning to do, to find out if their pattern of cortisol secretion is different. But at the time when we collected the data, most participants were collected, their blood was collected a similar time during the day. So let me go to that. So the collection time for healthy control, the convalescing control, or the long haulers were about similar time from the
So Kiko, let me ask you this, just because
Sure.
you've got a lot of good, amazing stuff here. So just because I'm thinking, you've got such good detail, but a lot of people will like, I think what we want them to take home from this is that you've got your approach is, let's measure thousands of different things, multiple different domains. I mean, and just for people listening, I mean, look, Akiko, as you can tell, is like at the top of the field, and there are others, of course, who are thinking hard about this stuff. But one of the central messages from the study was that there was something there. So all these people generally had, lots of other tests. And I'm seeing I'm just saying this because we're also getting questions and I want to be able to get to, but people are getting lots of tests that were all come back normal. And then with this vast array of testing, many of it in very different, kinds of things, some looking for substances produced by the immune system, some produced by antibody proteins, some being looking at evidence reactivation, all this kind of stuff, that people who, and this is just long COVID, we didn't have a vaccine injured, that we're hopefully develop cohorts like that, but people were different. People were different. I mean, and I think that one of the central things I've been telling people is, this is evidence that when people are saying, I don't feel right, and then people are doing a bunch of tests and they're saying, I can't find anything wrong with you. Well, maybe that's not me, the person who's telling you something's wrong. Maybe it's the tests that, and we don't yet have the right tests that are detecting what it is in your body that's not going right, at least as different than it was before, that's causing you to feel a whole bunch of symptoms. And one of the things that's interesting about Listen is, with more than 600 people in Listen, and people haven't filled out a lot of these profiles, is that people are severely affected. So, remember that scale that was 0 to 100? Like if you go out to the, the United States general population for the age group that we've got, people aren't in perfect health. Their numbers are something like 84, 85, something like that. That's the average score that people will say when you say, how's your health? And in this group, it's 50. It's 50. And many people were down, and I'm just telling you what you already know because you filled it out. Some people are down 30 and even lower. And showing that, people are severely affected, and lots of people were representing their previous lives as very healthy. I mean, and many people, marathon runners, doing all sorts of things. So what the most important thing, I think, what Akiko is showing is that we actually, she in her lab and all the people working with her, I like to say we, but really it's her and her lab, are detecting very important changes that have occurred. We believe changes is cross-sectional, but that differentiate people who are reporting all these symptoms from people who aren't reporting all these symptoms. And again, we think it's the first half of the first inning. It's just the beginning of unpacking all of this. But like when you're seeing all this, these numbers, I know it can be overwhelming, the amount of information, but I think we wanted to give you a sense of the substance of the work that's going on. But maybe I'm just thinking, Kiko, it's we got 20 minutes. Maybe we can just start taking some questions. And a lot of these questions, by the way, I think I'm interested in hearing what you have to say about them, because a lot of them are really tuned towards people having already had other tests and stuff like that. And I'm just thinking, for some people, this might be it's great to get the high level, but let's maybe just get into some of the questions. That'd be all right.
Of course, it's fine. I'm sorry if I went on and on about.
I could listen to you forever, but also I got a lot to learn. Even when I'm listening to you, I'm thinking, there's more I need to learn to get up to speed, because it's so deep and broad. But it should give everyone a sense of the depth here. That this isn't just like one test or another test, but it's like it's a depth of information, which she was sort of showing you, that we're looking in this way, that way. I mean, the immune system is amazing. I mean, and the body's amazing. And there's so many different ways that we can look at this that are far beyond what our traditional tests people are done. So maybe we can just go on. One, does vascular endothelial inflammation fit with the hypothesis B of autoimmunity? I don't know if you want to give your opinion about that.
Yeah, it could be autoimmunity. You can imagine antibodies that are binding to the vascular endothelial cells, causing some inflammation. It could be complement deposition. It could be inflammation itself that's causing vascular damage. Yeah, so there are a lot of possibilities of how vascular damage could happen, but autoimmunity is one of them.
And I'm going to just pepper you with these. Like, I'm just going to go fast. So if you don't mind, put you on the
Sure.
hot seat. Okay, if you think I'm missing anything or you think there's something else, but this is regarding the theory of viral reservoir. I'm vaccine injured and have had my COVID antibodies checked 8 weeks from injury and had never had the infection. No nucleocapsid antibodies were found. So it's autoimmunity for us. I had an immediate reaction, dizziness within minutes of the shot. And then someone else said, you know, they were sorry to hear that, and that they had both post-booster and post-infection long COVID. After Pfizer booster, I could barely stand the next 5 days and barely walk straight for the following 2 weeks. Even now, almost a year later, I can't stand with eyes closed, might bounce off. Let me just say, when I'm saying these, when we're talking about these things that people are suffering, I mean, my heart hurts to hear them, but we'll try to go through these quickly. But I want to say to each and every one of you that I'm sorry for what you're experiencing. We're trying to move forward. But I think this was just a question of whether or not your thoughts about vaccine injury, and are we going to take the same approach to look at it, or are there special features to it?
Yeah, great question. So I'm sorry I didn't get into the vaccine injury hypothesis, but other than the viral reservoir, which obviously isn't part of the vaccine, I think all of these hypotheses can still hold true. And that's why we're very excited to compare vaccine injury versus long COVID. We now have really a lot of insights, which I was sharing with you about long COVID and immune phenotype. But for post-vaccine, it's possible that these 4 hypotheses, except for the viral reservoir, I would replace that by potentially the antigen reservoir, but we don't know. We don't know whether the spike itself can be triggering the chronic sort of activation of T cells and B cells. And that we can tell by looking at the flow cytometry data. You know, I was showing you the activated B cells and T cells. This is a feature that we can immediately sort of decipher by doing a similar study on vaccine injury. So if the injury happens within minutes of the first vaccine, though, it's unlikely to be driven by adaptive immune response, because adaptive immunity takes a couple of weeks to develop. So if it's within minutes, you know, you may be reacting to components of the vaccine in either sort of an allergic manner, or it's possible that you may be reacting to the through the innate immune response to the vaccine that somehow cannot be repressed later. So, but if it's happening after the booster dose, it may be driven by adaptive immune responses that you generate with the first primary series of the vaccine. So I think we have to be open-minded about what might be causing those.
And that's why we're trying to get as many people. We're going to start implementing this part of selecting certain people to see whether they'd be willing to provide blood and saliva so that we can run some of these same tests. So here's another one. Do you think it's possible for dogs to recognize injured vaccine injury? And are they recognizing virus or the combination of the immune response present with the virus?
Yeah, first of all, we don't know what the dogs are detecting, the volatile organic compounds that the dogs are sensing. No one has identified what that is, so we don't know. It would be pretty amazing if the dogs can recognize the vaccine injury, because that would very much suggest the spike, you know, because that's sort of the common thing, that they've been trained with the viral infected supernatant. Unless it's something that's induced by the infection, that's also induced by the vaccine, that has nothing to do with the spike, it's possible, right? But like logically, spike would be the common feature there. So yeah, it would be great to see if the dogs can recognize vaccine injury.
I thought there was another one that just disappeared, but I'll go this one. I was told by long haul COVID clinic at Johns Hopkins that Professor Pretorius is currently affiliating her research with Yale. Is this correct? And if so, we'd be following up with the microclotting studies and potential testing.
Yeah, definitely. We've been in touch with Dr. Pretorius's group, and we are learning how to do the microclot analysis in the lab. You know, we have very limited number of people in the lab, so we can't do everything. But microclot is certainly on the radar. It's not like the central focus right now, but it's something we'd like to do in the future.
Great. I think maybe asked just about the theories about vax injury, but I think that you covered your thoughts about the vax injured hypotheses. There would be maybe even more that you thought, but let me go. Will you be testing or looking at immune mediated small fiber neuropathy related antibodies, TSHDS, FGFR3, MAG? Many of us with chronic neurologic vaccine reactions test positive for small fiber neuropathy via skin biopsies and are sometimes positive for these antibodies.
Absolutely. So there are two technologies that would cover those. The REAP that I was telling you about, which is a human exoproteome antibody analysis that Dr. Ring's lab has developed. It covers over 6,000 proteins. So many of these are in that, at least fragments are in there. So if you are developing autoantibodies, we would be picking them up. The other strategy that I mentioned is the phage display library. That one can also pick up antibody against any epitope. So we should be able to pick those up. So yeah, I mean, whatever it is, we are going to find it.
Someone asked, why was it that injured folks like me who clearly have SFN are showing negative test results? I think that's a question.
Yeah. So, you know, if we only did 10 tests, we would also not find much in long COVID. We did thousands of, we tested thousands of parameters, and that's why we were able to identify distinguishing features for long COVID. I think this wide net sort of approach that we're doing will reveal something common in post-vaccine injury. So I'm hopeful that we're going to find something. But, you know, standard lab testing will maybe not pick up the key features that we are able to pick up.
And Michelle asks, is there a specific anti-SARS-CoV-2 IgG test that we can take that will allow you to capture the same kinds of readings? Many of us have had antibody tests, but different types, Quest, LabCorp, academic centers, Radiance. So it's harder to compare.
Yeah. So in our preprint, we also found that people with long COVID make antibodies to specific epitope within the spike that is not found in the convalescent controls. So it's something that's induced by the features, viral features associated with long COVID. And it's not related to vaccine status because we compared people who are vaccinated. And so it's possible that the molecular kind of analysis that we're doing will pick up unique features of your antibodies. Yeah, it's not a standard sort of Quest type of testing. So yeah, I'm not sure whether they're going to pick up any differences.
Yeah, and I think you really have to have the laboratory research test to get the kind of things that you're doing, which again, the reason for the study, those antibody tests may give you some information, but not exactly what you've been looking at. Someone's asking, based on your tests, whether people should be going out and getting cortisol tests.
Yeah, so that's the other thing. I don't want to, you know, first we need to do more research. You know, it's a limited number of people and it's one site. And that's why this LISTEN study is great, because we can, you know, in a decentralized manner, we can collect samples from many of you and test it. The standard sort of, you know, clinical cortisol test, we don't know whether they're going to pick up the difference. If you're doing it for some reason anyway, yeah, why not? But I cannot promise you that that's going to be a sensitive way of detecting the differences. So again, we do have to do some head-to-head comparison. Yeah.
Yeah, Karen asks, have you considered running these same tests as a group of vaccine injured that have long COVID type symptoms? I'd just say, I can just pick that up, say like that's in the plan. Actually, we're starting that. Now we're already contacting a few people to get started on that, but that's exactly what we want to do. We want to demonstrate, what do people's, Kiko start calling these immune signatures, what is it that looks like that's going on in their bodies? And can we learn from that? So that's definitely in the plan, soon to be launched. Will there be translation of these findings into clinical trials? So what's timeline been? I'll just say quickly that, Kiko and I recognize that people are suffering and we can't wait for a full understanding of this condition in order to move forward. And I'll give you, there are lots of situations in medicine where you may not fully understand something, but you have some hints of things that are worth trying, and they actually can give insight into the underlying cause too at the same time. So we are eagerly moving forward to try to figure out how we can use this platform to run trials and to get candidates based on what we know already. We're in discussions. Actually, there's a potential trial that could run as soon as in a few months. And we're hoping that we'll have a bunch of people from this community ready, eager to go, and we can enroll it within weeks, run it, within a month, and figure out the answer and then keep going. And then we're all the time talking to people who may have therapies that we can try. And if this group is up for it, then, we'll be able to learn stuff rapidly. But I think it's essential that we do this in rigorous ways with trials. Just to bring in a few other people who haven't asked, some of us, not all, seem to get significantly worse immediately after steroids, like prednisone. Maybe it's because prednisone also lowers cortisol for an already low cortisol subject. I'll just say, I think it's important for this group to share experiences about what triggers them, what makes things better, what makes things worse. We can continue to ask those kind of questions and collect that, share that information, and figure out other clusters of people who have the same kind of triggers. I don't think we know yet, have a strong enough evidence base to be able to say that reproducibly, because some people are, have even reported steroids help them. Some people report it's made them worse. It's hard to know, but we need to, if we can get a bunch of people who are having different reactions, then be able to compare them with many of the tests that Kiko's running, maybe that'll provide some insight. Can you talk about TNF? Mine was very high. Also, there's overlap with reactivated viruses, chronic Lyme. What's the spike protein? And what have you attributed to other diseases? And have you seen anemia in the long haul? Vaccine injured and positive Lyme IgM has not converted to IgG. You have any comments on that?
Yeah, so we did measure TNF. It's one of our cytokine that we measured. The
And just to say to people, just some people may not know, a cytokine is a substance that's released in the course of a response with the immune system. I mean, you can do a better job of definition, but it's just, I'm just assuming people, even that word might not be familiar to many people.
Sorry, yeah, cytokines are, like I said, language that the immune cells use to communicate with each other. TNF is one of the loudest alarms you can imagine. TNF, IL-6, IL-1, these are cytokines that is released during an acute infection, bacterial or viral. And if you have high levels of TNF, you're not going to feel well because it has many pleiotropic impact throughout the body. Anyway, we did measure TNF and it's elevated in some people, but not others. It wasn't one of the significantly different factors, but I wouldn't discount that as a part of the, pathological process. We did also look at antibody to many pathogens, including Lyme antigens. And we did not see any significant difference between the long haulers and non-long haulers. But what I didn't get to in my presentation is that we did see the Epstein-Barr virus reactivation feature in our antibody. So that's one of the highest feature after cortisol that is different in the long COVID patients.
And that was a great question, a great answer. Just to confirm, study found higher levels of cortisol long COVID. Actually, it's lower levels of cortisol in the long COVID patients. This was nice, Professor Saki, even though I don't understand all the cell biology. I find your presentation very engaging. Hope to hear from you more in the future. That was just a lovely, and we recognize we need to work, this is our first one, and we've got to figure out how to calibrate the communication. Just, forgive us if we're still learning. This is about trying to figure out how we share information, and we need to, again, continue to do better about how we communicate, recognizing there are people with very different levels of backgrounds, and also many people still suffering brain fog and difficult concentrating. And maybe an hour presentation like this, we should just only be doing questions if people can even put them up in advance. We want to be as helpful as possible. Realize that every time I get vaccinated, I suffer many side effects for months. It's still ongoing. Nervous about getting the latest bivalent, but was told it's safer than actually getting COVID. What do you think? I'll take that as a clinician. I don't know if you have an idea, but I'm just saying, like, I don't know what to say in this case. I mean, I hear it from a lot of people. They're concerned about getting the vaccine because they've not had a great experience with it in the past. They're even more concerned about getting COVID. The vaccine, by the way, doesn't fully prevent COVID, as many of you know. It does mitigate the consequences of the COVID infection, and it may decrease the infection rate by some percentage in the same way flu vaccine, doesn't keep everyone from getting flu, but it reduces the risk and reduces the consequence. This is just a really hard one. I don't think we want to be giving medical advice here, but just to acknowledge that that's a tough one.
There are a few questions regarding medical records. People are asking what is the timeline for them to connect to medical records, and what records are we expecting from them?
So I think I'll just take this one. So the idea about, for example, first I'll just take the surveys. So you've been asked to fill out surveys in Kindred and then come into Listen. All those surveys help provide profiling information, and we're likely to then augment that information with more information as we learn more about people in the study and figure out what we need to dig into more detail on. And one of the innovations of the study is that rather than having you give us permission and then going to every healthcare system and then, believe it or not, faxing them consents and then waiting weeks before they give us like paper copies of the records and then having to go through them and abstract them. We're using this digital way, and the way the digital way was worked, you connect to your records or wearables or everywhere you've got your data assets, your personal data assets comes into your own cloud-based account. One day, sometime in the future, we'll be able to actually show a viewer where you can see what you've got. We don't have that yet in Hugo, but it comes to your cloud-based account, and then with your permission, it's going into the study. And the way it works is once you've connected to your records that way, it's being refreshed all the time in your secure cloud-based account. And if you've given permission for it to go into the study, it moves into the study and kind of keeps the study all updated. If you ever decide you want to stop, you can just stop. It just stops. If you ever decide you want to delete your records, you can delete your records. But meanwhile, your data assets are growing. And all we're encouraging is the more places you connect to, if you connect to your health systems, the health systems where you've gotten it, who have electronic records where we can make this connection, pharmacies like Walmart, Walgreens, Kroger's, anywhere you've got large major pharmacies or labs or wearables, the more data assets are growing that can help the study to have more insight into your journey and what's going on with you. So we're just, and part of this, we're trying to learn together. You could come and tell us it's too burdensome, it's hard, or what you're encountering as challenges. And we want to be able to hear that and figure out how we can make it better and easier. But the alternative is a really labor-intensive, difficult, and delayed process where everybody goes out and tries to get records. Then I can go out and get your records, but then more things happen and we got to go out again. But with this digital process, we protect your privacy, we protect your records, only everything moves with your permission. And then, but stuff is constantly being refreshed, and the study can continue to follow people over time. Once you're connected, it's automated. But that's the way we're trying to do this as a new approach. You look like
I just want to add too, because I think people are concerned about the Kindred side of it, and that is how Kindred is built. So there's nothing that will happen to your records in Kindred. We assure you that nothing moves without your permission. The only place we're sharing it is with Listen, if that's what you've given us permission to do. But that is, foundational to what we are doing on Kindred. They're your records, and you have control.
Yeah, and that's the other things, like Kindred doesn't own your data, Hugo doesn't own your data, you own your data, and everything is permission based. There's no back end selling, nothing. It's it's a matter of trying to put people in a position where they gain agency over their data and then can be parts of studies where they're allowing that data to come into the study. But that's the way we're doing this. I know we're at time, and I know we could have probably done a lot of things better than what we did. And there's lots of questions here. So I think that we can be looking at these questions and kind of bring some of them together and then share them back through, an email or something to all the listen participants, and they'll learn from these important questions that people have raised. I see lots of people here as I look down here that we have just so appreciative of all of you and that you're being part of this and helping us do better. And we can definitely answer these questions. And when we don't have answers, we can just be honest with you and say we don't know, and that we hope we will know soon. But I don't know, Kiko, I'm trying to just be respectful of your time and everyone's time. We have a lot more questions. Let me just say we're committed to getting information back to you with these questions. So don't think that we're going to ignore them. But Kiko, do you have anything you want to say at the end?
Oh yeah, absolutely. So yeah, maybe I can do another one just to complete my presentation. If anyone's interested, I'm happy to come back and do it. The other thing is that, we really don't know much about the vaccine injury, and we're very eager to find out what's going on. So it's just a matter of starting the study and with your help, understanding what's going on.
Yeah, and the idea generally is like we should have regular town halls. We should continue to interact with people who are, all of you. And by the way, you can reach out to us other times too. Like it's not just constrained by this. What does it say? It's our listen study at yale.edu. Anybody can send us an email at any time. And, the notion should be that we want to, it's not like we're the researchers, we don't want to hear from you. It's just exactly the opposite. And but we need to learn, like, how do we do this? How do we make it better? How do we interact appropriately? How do we communicate clearly? And yeah, and Kiko, it's not just, like we just regularly come back to this group. And if it's a ton of questions, then we can just spend the time answering questions. And I think also if we can figure this out where it looks more like a meeting where everyone's together, I think that'll make us all feel good too, that there's a large group of people who are all part of this together. But just again, I've said this to everyone and listened before. Deep gratitude. Leslie's telling me there's 656 people in listen now. That's pretty good. As a number of people growing by word of mouth, we've had, I think 80 some people on this call. That's a pretty good percentage of people who are listening. And we're just open to ideas. What we really want to do is grow this community. We want to make it as big as possible, bring in, and more people we get, the more we can learn from each other, and also start really revving up this immunophenotyping part for listen, so that we can start to have very detailed information that we can leverage to bring some answers. So with that, I just, like, this isn't like, okay, we're over. This is just like this hour's over, but we're going to continue to be involved and communicate. And yeah, thanks, Kiko, great job, and Cesar and Bernali, and for everyone who's got questions. And I'm looking at these questions is terrific. So this will be great for us to get back to, Bob.
Thank you,
you.
everyone.
Thank you, everyone.